Welcome to this week's webinar.
Hola a todos, bienvenidos.
Welcome to this week's webinar. I hope that all of y'all can hear us. My name is Mary Chapman, and let's get started. This is a webinar on Windrock MD.
Nuestro software.
With this says Jonathan, but it's actually Tony. If you need to, these are the instructions. If you go to interpretation and then go to English or Spanish or whatever, that way you can listen to either English or Spanish. I'm going to have a little safety moment. With all the
con un momento de seguridad.
There is some uninvited guests and they're hacking into Zoom meetings. If this happens, we will end the session immediately and just log off your computer and we'll reschedule the webinar. My name is Mary Chapman and I began my career with Windrock in 2013. So I've been working there about 7 years. But I have 30 years of experience with predictive maintenance and reliability. I spent 25 years more on the rotating equipment. That's motors, pumps, fans. So I've been involved in reliability for a long time. I've been with Windrock for about 7. Rocky's here. I was going to let Rocky introduce himself.
Hey, hello everybody. My name is Rocky Otterson. I am located in Oklahoma. I'm one of the field service analysts in the group. I worked on, my history is I've worked on Cooper Bessemers, GMVCs, GMVHs, Ajaxes, and now I go out and collect data on a variety of different configurations of compressors and engine driven. And so today we're just going to talk about some things that are pretty important and one of the really big features with Windrock. And so I'll hand it back to Mary.
Okay, thank you, Rocky. As I said before, y'all can see Maria and Tony. They're doing our Spanish interpretation. This is the first time we've done the interpretation where we are doing live demos. So be patient. They're having to listen to us and then try to translate on the fly. What we're going to do today, I'm going to spend just a few minutes doing some company background. We do that at the beginning of every webinar. And then we're going to go into Windrock MD features. We thought it would be, there's no way that we can hit every feature in Windrock MD. There's 25 years of programming in it. So since we did a webinar on pressure curves on compressors, we thought we would focus on the features that deal with the pressure plots. Hit a lot of the icons. Plus, we're going to try to do some hidden gems to make your job more efficient. Windrock is a part of Apergy, and Apergy used to be Dover Corporation. It's a combination of about 15 different companies, one being Windrock, all in the oil and gas industry. So it's everything from downhole monitoring to artificial lift, automation technologies, but all in the oil and gas. Windrock originated back in 1996. They were a research and development company or arm of Computational Systems Incorporated. It's now Emerson. I used to work there at the time, so I was familiar with Windrock 25 years ago. 3 employees took and formed Windrock in 1996. There's different products. The first one was a portable analyzer. We're in our 4th generation, the 6400. And then they started online monitoring in 1999. The first generation was the OnGuard system. Then in 2009, the auto balance was introduced. That's for automatically balancing slow speed intervals. Recently, in 2014, we released the 3rd generation, which was the Platinum system. And in 2018, we released a online system, more condition monitoring, called the Spotlight. a little bit deeper dive into these. Platinum is your Cadillac. It looks at every single revolution. We'll do calculations, whether it's a compressor or an engine. It looks at horsepower for every revolution. Is also your shutdown protection system. The portable system is typically our customers take data once a quarter. So Spotlight's kind of in between these. It is an online system, but it typically takes data once an hour. So it gives you some of the advantages of online monitoring, but at a much more affordable cost. It's low installation cost. You can get one of these installed in a day. Which is our cloud-based system where all this data can accumulate. Windrock MD is the analysis tool. And I hope y'all can hear me. Something just came on my screen that said my internet was unreliable. As most of y'all know, a lot of us are working from home, so I am not in the office right now. These three products are really set for different assets. On your critical assets where you need shutdown protection, that's where the Platinum fits in. For all your essential assets throughout your plant, you would use the Windrock or the Spotlight system. Now, what I'm going to do is I'm going to stop sharing and I'm going to let Rocky start sharing. And I'm going to be answering questions. You can see that there's a Q&A. So I'll be answering questions while Rocky's going. Rocky's going to do half of the features, and then I'm going to take over and do some other features for you. Rocky, here you go.
All right, thank you, Mary. Good morning, everyone. So as you can see on my screen, I have the Windrock MD software up. It might be a little different from y'all's version, just because this is a beta version that should eventually will be released to everybody. And there will be some new features with this new software. And I know Mary's going to touch a little bit on those features. But today, you know, my thing is I want to just talk to you guys kind of down at the basic level, and then kind of talk to you guys, you know, about just the pressure trace. You know, what's it about? Where's it coming from? And kind of how to interpret things around it. You know, some engineers, you know, can learn from this, managers can learn from this, and then other analysts can learn from it as well. So let's get this going. All right, so first thing, what I want to do is click File, and we're gonna go to Open. And as you can see, we got a database already. And then you can see at the midstream, we're going to talk about this catenary combination, and you can see it says discharge valve, and we'll talk about that in more detail. So as I open it up, it gives you a blank screen. And what we want to do is bring up a compressor pressure. So what I want to do is click on this plot data, click on it, and now it gives you the point selection, the date, and then how many runs and at what times those runs were completed. But as you can see, there are quite a few listings of different things. So let's just make it fast. There's a search bar at the bottom, and if we type in compressor, and you can see they're starting to come the head ends and stuff like that. So this particular reason, we're going to start with compressor 4 head and run number 1. So as we bring this up, as you can see, we have a XY plot. On the left-hand side, we have the pressures, and on the bottom, we have the degrees of rotation. And then in the middle, as you can tell, here is the pressure trace. So this is the pressure trace for the number 4 head data collection point. What we want to talk about is, from this, we can't really troubleshoot. We're just looking at pressures. Well, what features we want to talk about now is just the theoretical. So at the top of this, there is a box drop down or icons, and we can click on theoretical. As we click on it, now we can see there's a difference between the pressure and the theoretical. The theoretical is just basically in the perfect world with the clearances and the gas sample analysis that you take from the gas sample. That's what that line represents. If in a perfect condition, if there was no leakage, that line would follow that line to a T. But in this case, it doesn't. We're not going to get too much in troubleshooting, but we're just going to talk a little bit about it. As you can tell, there is a difference between this one, the pressure trace, and the theoretical. Now what we want to do, we don't just want to troubleshoot and just use one thing to figure out to troubleshoot, but we're going to look at a little bit more details of how can we interpret this pressure data. So at the top, we can switch from a pressure trace to PV, pressure volume card. And so now we have a pressure versus log, and this is just a different look at that same pressure trace. Now, different people are going to have different, they're going to look at different things and interpret data differently. So now, since we have the pressure log up, let's look at it a little bit different, another way. Now we have a log. The log is derived from the in expansion line and the in compression line, and it gives you the in ratio, as you can see right here. In this particular trace, you can tell there's something's not right because the in ratio is a lot less than the in compression line, and the in ratio is just really low. So now let's look at the clearances as well. So in this particular log or pressure trace, you can see the geometry setting is at 29.02, and then there's a suction calculation, a discharge, calculated discharge, and a calculated average calculated. If you know your clearances in the particular cylinder, you would always want to set those up and use the geometry setting. Sometimes you'll just, typically what we use is the average calculated. And we'll talk a little bit more about the suction, this calculated suction and calculated discharge. Usually when you're when everything's great, those clearances are really close. Okay, so now we looked at that real quick. Now let's go back and let's bring up the second run. So we brought up the first run, and now we know we had a problem. There was a discharge valve leak. But now let's bring up the second trace. So this is the second trace. Now you can't really see anything because there's no theoretical. So once again, let's go back to the theoretical. And this theoretical, what we use is the equation K. And you can actually change this in the setups by clicking Setup, Software Options, and then as your gas composition, if you have CO2 or other weird gases, you can actually change this in the theoretical model. And you can play around with it if you don't know exactly what you got. You can say ask each time, or you can do the K base, the N base, average N base, or the equation state of K, which is typically what we use. Now let's bring up the theoretical. As you can tell, there's a big difference between the first sample and the second sample. The theoretical and the pressure traces are really close, right on top of each other. So let's bring up the PV again. And now you can see there's a big difference between this on the expansion and the contraction, they line up with each other. Now let's look at the log. Now look at the in expression and compression. The numbers are a lot closer, and your in ratios are a lot closer as well. Typically, the in ratio is, perfect conditions would be 1.00, but that's perfectly acceptable at that 1.04. Okay, so now we talked about that. Let's talk about some other features with this. Also, let's look at the clearances again. We talked about where the geometry clearances are, the calculated, the discharge, and the average. Now, as you can tell, they are getting a lot closer. So if we click on the average calculated, now we went from the in compression at just 1.24 and the in expansion to 1.3, and it still gives you the in ratio of 1.04. Now, what we want to talk about next is I'm going to bring up a different machine. So we're going to close that one out. We're going to go to File, Open, and then now what we want to do is we're going to bring up this particular unit. It's a refinery unit. It's a clogged discharge valve. So again, there are several ways you can bring up plots. This time what we'll do is we'll just bring up a multi-plot. So in this, which I kind of gave you away right there. So we're going to look at two different sample dates. We're going to look at the 5/21 and 13. As you can tell, this looks pretty normal. And then there are some hotkeys. If you can hit Control up and down, it kind of actually goes to the next date, the previous date. So if you just type Control up, down, it changes the date for you. So on this one, you can see they took data on 6/13/2013. And as you can tell, there's a big difference of like what's going on. That's not normal. Why is it when the discharge valve is opening, you're still getting you're still building pressure in that? So let's go back here and let's just talk about some other key features real quick. So there is a calculator tool, and this calculator button right here, we're going to click on it. And this is going to kind of break down just different features that Windrock has to offer, which are very good for troubleshooting and diagnosing things. So you have indicated horsepower as right here. You have the RPMs, you have the toe pressure picks, the volume efficiency and power losses, and then the flow balance. And of course you have your clearances on the back. And down below is really cool. That's proprietary to Windrock, and it's called the leak index. And there's in Oklahoma, you know, we need all the help we can get. So it's really nice to have this leak index, because it just basically says, hey, you got something wrong, you need to fix it. And it will tell you, do you have a suction valve leak? Do you have a suction valve or ring leakage? Do you have a discharge valve leak? Or it could be on the crank end, could it be a packing case leak? So it's a really helpful tool that really helps analysts out, just to kind of help troubleshoot at the beginning. So now let's go ahead. Let's take a key feature of this. So we're just going to look at this particular, the power loss. As you can tell on the crank end, it's about 10 or 9.9. So let's close out the calculator tool and let's bring up the newest data for this machine. Now again, all you have to do is hit Control up and it will change the date. Now let's bring up the calculator tool again. And as you can tell, look at the power loss now. Now you're over 34%. I mean, a huge increase. I mean, you don't have to use the power loss to say, hey, you got a problem. You can say, hey, you've got a problem right here, because that's not a normal pressure trace. So now let's bring up the another key feature, and this is called the valve loss. And this is basically everything in this box is work. Everything on the outside is nothing. It's losses. It's inefficiency. As you can tell, it's going pretty good right there. Now let's bring up the other date and look at the big difference. Look at all that red area. So right there, you know, the machine is working a lot harder than what it should, which is, you know, it's still pumping what it needs to be pumping, but it's it's at the cost of the compressor. It's working harder, it's using more electricity, and it's costing more money. And that's at the bottom line. It's how can this software save us money, make it more things efficiency. And that's a big key feature with looking at the pressure traces. We can look at the log again, and you can see there's a big discrepancy from the head end and the crank end on 613. So from 521 to 613, there's been an issue. So, having a reliability program where you're out there checking the compressors routinely is a very good thing for your reliability group, because you just never know what's going to happen. Okay, so we talked about that. Let's talk about a couple other things real quick. Just give me 1 second. Now, what we want to talk about is I'm going to show you another machine. So we've looked at 2 different machines, one with a discharge valve, and then now with a clogged valve, a discharge clogged valve. Now let's look at sometimes when people go out and take data, sometimes it doesn't make sense, because when we take data, we don't know if we're in this, where TDC is and top dead center. And sometimes when you get data, it looks like this. So what I did is I brought up a Cooper Bessemer GMVH 12, and this unit, it's a 2-stroke unit. It's out in the kind of in the storage field, so it's actually at 2 stages. Later in the summer, basically they inject gas into a field, and they store it for the winter, and then they draw it out in the winter. So basically injecting in summer, withdrawing in the winter. And so what we're going to look at about this is, my takeaway from this is, how do you know your TDC is reliable? So as we can see, we brought up a pressure trace, and then now let's bring up a report. So let's click on review report. And as you can tell, there's a breakdown. So since we're talking about just a particular thing like compressor pressures, we're just going to bring up compressor report. So all you do is click on compressor and then click preview. There we go. All right. So on this page, it kind of breaks down everything, some of the geometry, the clearances that are in it, the pressures, the temperatures, compression ratio, the calculated clearance, the horsepower, the suction losses, discharge, flow balances, the deltas, rod loads. And so what we want to talk about is, as you can tell, if you look down here, we have an indicated horsepower of 397. And then one particular thing is, look at the percent torque load. It's at 19.5. We obviously know this is not the correct TDC, just because if you look at all these blank numbers and everything's unloaded. So let's go ahead and let's modify. Let's use this new feature, not new feature, but this modified remove line. So up at the top of the icons, you can click on the scissor tool. In the scissor tool, you can bring up this modified day offset. In this modified day offset, what we're doing is actually we're moving this TDC around. So we're moving the pressures left or right of the screen. So if we add a 50-degree offset, as you can tell, the pressure is starting to move to the right. Now we know this is a head-end pressure, and so we're still quite a bit of ways off. So all we have to do is keep adding to this. So we're going to add 100. So as we get closer, the one thing we also want to bring up is we want to look at the clearances and this calculated tool. As you can tell, we're kind of getting close because the flow balance is starting to come in. At first, there was nothing there. It was just blank because it was saying, hey, we're unloaded, because the TDC was so far off. So now let's go ahead and add 112 degrees offset. Okay, so now it's showing that the calculated suction is still pretty far off. The average is pretty far off. The average comes from the calculated suction and the discharge, but the flow balance is getting there. So let's go back to view reports real quick, and let's bring up that compressor report. It looks a little bit different now because why? Because we're kind of getting closer to TDC, and now the clearances and things like that are coming into play. And look, now your percent torque load has come up significantly. It's at 89.5. But I think we can probably do a little bit better. So let's go ahead and add some more to this TDC. And now let's bring up the calculator tool again. So we're still pretty far off. So now we're going to keep adding. So we're taking some out just to see where we're at. Where are we at? So bring up this calculator tool again and see we're still pretty far off. So you have to be careful because you can go one way or the other and it will kind of mess up your data. So TDC is one of the most important things when you're going out taking data. You need to have TDC. So let's go back to the 116. Let's bring up the calculated clearances again. Oh, for some reason, it's not wanting to come up. There we go. Okay. So one thing you have to be careful of is when you're looking at these, the clearances, as you can tell, they're getting closer, but they're not precise. The reason why they're not precise on some of these is because you probably have leakage. You have a discharge leak, you have a suction valve leak, or you have ring leakage, or anything that's, you could have a gasket leaking. But as you can tell on the head end, it's actually pretty close. And one thing that I always tell analysts out there is if it's on a PLC, is to write down the horsepower and the percent load on the PLC, because it's going to give you the correct amount. And I knew when I went out there, or when the analyst sent me this, that was the one thing I asked. I said, well, what's your percent torque load? And he said, well, it's actually at 86. So I said, okay, well, without knowing TDC and being out there, and this has been a month later, I said, well, we're right there. We're within like 1%. So I said, this is probably good enough. And we discussed about why are the clearances so high? And of course, as you gain experience, the reason why is they had some leakage on the valves. So but we're not going to get into too much troubleshooting. That's for another day. And when I get a little bit more confidence of doing the webinars. So that's couple of key things that I wanted to bring up to you guys, is just a few little knickknacks, quick things like that. Now, I know Mary wants to talk, and so I'm going to go ahead and give control back to her and then try to answer some questions if you guys have any questions. One second. There we go.
Can y'all see my screen? Rocky, shake your head if you can see my screen. Okay. As Rocky said, what I'm going to do is I have like 3 different machines, and I'm going to try to hit a lot of the icons just to give you an idea. And I'm going to show you kind of how I use Windrock. Everybody uses it a little bit different. That's why these things are so good. It seems like every time I'm training somebody, I actually learn things from our customers. As Rocky said, this is the new software that we've been testing. It's going to be released in the next probably couple of weeks. I'm going to go over, there's probably 3 features that I will be going over at the end to show you some of the things that were added. I'm going to hit open, and I'm going to go to a portable. So I have different databases. This is one thing. When you first install Windrock MD, it automatically makes an EV port and an EV online. I like to divide my data up. So I have my online data. We were talking about Platinum and Spotlight. So my online data has my Platinum and Spotlight data, and then portable. This would be the 6400 or 6320. I am one of the Spotlight analysts, so this is actually on my customer database. So this is one thing you can do, is create different databases. You can see down here, create new, and just follow the steps. But I'm going to go to portable, and I'm going to go to, this is the hydrogen compressor 2. Open it up. I'm going to hit, Rocky talked about group plots, and he mentioned multi-plots. Multi-plots is actually this icon right here. You can see it says multi-plot. Now, group plots are predefined ways you want to look at data. When you are going out there taking data, you can have 100 different points, and to look through each one of those or select points can take a lot of time. So you have the ability to define these group plots as you need to or want to. I typically will also include multi-plots, and just to give you an idea, you can have a multi-plot of 2. You could have a multi-plot of 6 by 6. This one is a multi-plot of 3 by 4. So I'll go back. It's predefined. So after taking data, you come and you dump it. This is a make up and recycle. You can very quickly, you're looking for things in here that are obvious because they're pretty small pictures. I'm actually on my laptop right now, which is where my camera is, but a bigger screen, I usually use a bigger screen. I'm going to go to the recycle side. Once again, we've been talking a lot about pressure traces and pressure volume curves. We'll talk about rod load here in a second. Any one of these you can double click on. Since I'm on my laptop right now, it's a pretty small screen, so I can analyze. And now I bring this one plot up in full screen. There is a lot of things that you can do with this as far as while you're analyzing. And we're just going to go through one of them. This is one of my favorite features, and it's it's one of those hidden gems. In the past, you had this zoom, and you could click this icon. I could come over here, drag this, and zoom around. Then if I wanted to go look at something else, you know, I could click it and do that. Well, we have this feature if you're using a mouse and you're inside this box. If I just roll the mouse, it starts zooming in. So let's say I want to see if there's a rounded toe. I can zoom in and see, yep, there's a little bit of a rounded toe. That's typically an indication of ring leakage. The other thing, so I'm inside. I can also move it around. So if I'm like this, I can move this way. It just helps you do the analysis. The other thing you can do is if I put my cursor on the outside and I start rolling my mouse, see how it's expanding the bottom? and I'm going to bring it back, and it's going to go back, we'll go back to the 0 to 100% sweat volume. Same thing over here for the pressure. Now, that's one way you can do it, but the other way you can do it is just to go into auto scale. If you click, this is a scaling, and we have auto scale and fixed scale. Auto scale will pretty much fill up the whole screen. I personally don't like this because it puts the top of it. I like to use fixed scales. And you can see right now that this is saying the compressor, the fixed scale for this stage is between 500 PSI and 950. That means every time I bring this up, this is what it's going to be used. If you go over here and go over to setup, go to fixed data scale, and you can see for stage, that's where these numbers are coming from, this 500 to 950. So when you're setting up a database, and after you've looked at your plots and you know what your pressure is, what you can do is come in and change your low and high. But you can actually do it on the fly. I probably want this to be filled up a little bit more, so I'm going to go to fixed scale. I can see I'm going to put 550 right here. And then I'm going to put, let's put 900 here. So you can see now that that's changed. I'm going to save this. Now, when I save this, what that has done is it's actually changed my fixed scale. So if I go down here, those are the numbers we just put in. That is a real quick, easy way to change your fixed scales, is actually with this scaling button. Another feature, I'm going to go back to the PT. So Rocky kind of talked about switching between a pressure trace and a pressure volume. This is a cursor. So I'm going to hit a cursor, and sometimes you want to know what the different pressures are. If you select pressure and see I'm starting to move across, now that's showing me, if I look over here, and the red line, which is my crank end pressure, is at 840. My head end is at 580. But there's also this little graphic. So as I'm moving it, you see that it is moving to bottom dead center. And you can even see the discharge valve is open right here. When I hit bottom dead center, that discharge valve would close, and now it starts going back up. So this is the cursor. We talked about the scale. We've talked about the cursor, the zoom, the way you can use your mouse to zoom, and we talked about the scaling. That's just a few of the things on this one right here. I like this machine to show, like I said, the multi-plots. I'm going to switch to another machine. And I'm going to go now to one of my online databases. And this is some spotlight data. Now, this is an aerial compressor in the midstream. Trend data, I never used when I was looking at portable data. I didn't use this icon very much. Trend data, if you're taking data once a quarter, you know, in a year you have 4 points. It's not really detailed. But as we're releasing these online products and people are taking more and more online, looking at trends becomes really important. So I'm going to focus on trend plots here for a second. Click there. Now, every time you take a pressure reading, there's all kinds of different calculations, whether it's capacity, your volumetric efficiencies, your flow balance, your leak index, as Rocky was talking about. I want to bring up flow balance. I'm going to click this. Once again, I'm trying to show you just some hidden gems and different features that I like to use. Well, I need to select the points I want to and bring them over here. Well, one way you can do that is just very simply clicking this. This will put it at the bottom. If I click this, it'll put it above it. Another thing, you can click here. I'm going to hold the shift key and click here, and then I'm going to move all of them at once. This actually removes all of them. But this is something that I started using in the last, I'm kind of embarrassed to say this, but I just started using this in the last, one of my colleagues showed it to me, and it's so much easier. I click and hold, and you just drag down. So you don't have to hit the shift, you don't have to select, you just click, hold, drag down, get all the points you want, boom, you put them over here, and you hit OK, and now I'm ready to do my trend plot. Now I'm going to do 360 days. I don't have 360 days, but I'm going to do 360 days. Now this is, remember, this is a spotlight system, and so we're taking data once an hour. I picked this one because I think it's pretty interesting. This is kind of on a side note, but we started taking data. One of the features that we have is if you hover over, it's going to actually tell you what the date is and what the value is. So you can see, I just kind of go up here, and we started taking data last year in July, and the data is going through March. I had to count January, February, March. So this is data on one machine. With the spotlight system, once again, on portable systems, you're typically looking at every single pressure curve. But when you're taking data once an hour, that becomes just too much of a daunting task. You can't do it. So we really rely heavily on the flow balance, the N ratio, the leak index, all the things that Rocky was talking to you about. We really rely on those. But what I think is interesting about this is on this one compressor, and 80% of problems are leaks in compressors, but notice you had cylinder 1 head in, it had a leak. The customer, the flow balance got down to 0.7. They stopped it, changed it. Another leak on 4H, another leak on 2H. Here's one that actually was happening a little bit slower, and then you can see it dip down. This is typically what I see on this type of, when you're taking data once an hour, but there are some that will just very slowly degrade. But what I want to do is focus a little bit over here on the most recent failure. This was on 4C. You can see that it was running fine. It's about 1, and then had a little step change, and then a little step change. I'm going to kind of show you how I would use the system to look at the data. Now, one thing you could do is go over and hit here and go plot the data, but you can see I no longer have my trend data up, and I can't remember dates. So I like to have both of them up on the screen at the same time. So what I'm going to do, I'm going to go back and put that trend back up, just like we had before. And I'm going to use the multiplot. You remember I was talking about the multiplot a few minutes ago. Well, what I love about the multiplot is that it gives me a work area. So I'm going to click, and I'm going to have 2 multiplots. And I'm going to come over here. Notice anything I do, I'm going to bring up that 4C. So now I can do my work over here, but I can still look at my trend data. If you look right here, let's go 227. This window, I will say that if you click here, see the black, that means this window's active. Now this window's active. You can go back in time. This is my 331. I'm going to hit date pick. I want to go look and see once again. I have the advantage now. I have this up, and I can, even though this window's not active, it's still showing me what the date is. So you can see that's about 225. So I'm going to go over to February. I'm going to go to 225 and close. Well, I'll just keep that open for right now. Now this is, and then I'm going to bring up the theoretical that Rocky was talking about a little bit earlier. And if I go to my PV, sure enough, it looks like a classic discharge leak. So my flow balance is going down and my theoretical versus my actual, so it looks like it. Now let's hop over and see it right before they fixed it. So that's going to be 315. So let's go back over to March and let's hit 315. Look how much worse the theoretical to actual is now. So really the whole point of this is you can use your multi-plot to have different work areas that can help out. So I'm going to close this and I'm going to go back to my leak index, and I'm going to bring up another feature that I typically how I set up when I'm looking at trend data. And it's actually, we were talking about fixed scales. If I try to use a fixed scale here, notice it says no fixed scales are defined for this current plot. Now, when you first create a database, we create fixed scales for you. But there are certain points, whether it's pressure that, whether it's pressure that will not have a fixed scale set up. So we're going to actually go set this up. The main reason I want to do this is when I'm looking at this trend or really looking at any data, I want to normalize it. I want it, right now I'm 0.6 to 1.1. It might come up later and it's 0.8 to something else. So I like to normalize my data. And so I'm always referencing the same thing. So how you set this up is I'm going to go to fixed scales, fixed data scales, and we were here a few minutes ago. And since this is online data, there is a password. And you can see right now I have 3 fixed scales already set up. And when you click on any of these, it's going to tell you what points are used. But I'm going to add a brand new one. I'm going to call this my flow balance. And I'm going to say I want my low to go to 0.6 and my high to go to 1.3. You remember what Rocky said, that you're looking for a number of about 1. And I'm going to hit OK. We're going to save the changes. Now I've set up a fixed scale, but none of the measurement points are using it. So let's go to Setup, go to Trend Points, go to Setup. And I'm going to click. Rocky was talking to you about this search. I use this all the time. I'm going to put flow balance, use my click. I'm going to select all my flow balances. And you can see here it's saying to use auto scale. That's why this is why it's using the whole scale. But we're going to switch this. And now we're going to use the flow balance that we just set up. Hit OK, hit OK. Now I do have to replot that. When you replot this, now notice I have 0.6 to 1.3. So every time I bring this up, I'll have the same scale, and it's a little bit easier for me to diagnose an issue. So that's a little bit of stuff on trend data or the trend. I'm going to go back. Let's bring up, we're going to go back to our 4C. And once again, I'm trying to show you some different features. Let's say you want to look. We know this thing through time, through February. It was like February 13th. There was a little bit of an issue and it got worse and worse. So I'm going to pick the 3rd. And I'm going to pick, these are the different, you can see, remember I said we took data every hour. I'm going to just pick one of these. So we're going to take one from February 3rd. Let's take one from Thursday, the 27th of February. And then I'm going to take one from the 11th and one from the 27th. Now, I just picked 4 different dates on the crank end of cylinder 4. And when this comes up, I can't remember the dates. You know, I don't remember what it is. There is a little icon here called Show RPM and Timestamp. Anytime you click that, it's going to tell you the RPM and also the date it was taken. So I can see, okay, the blue one was taken at the beginning of February, the red one, and so on. So this is just another feature that allow you to give you information while you're diagnosing. Okay, let's see. Next, let's go to, let's go back to a PV, and we'll just stick with our, the leak that we had. So I'm going to clear this plot. I'm going to go to 4C. We're going to go back on the 13th. Let's clear it. When there was the leak. So now I have the up and the calculator. Notice, because I wanted to show you, I know we have about 9 minutes. I wanted to show you a couple of the new features. Rocky was talking to you about the discharge leak index. Whoops. And this is one thing. The other thing that this is just, I'll just throw this in. The other thing that's nice about the multi-plots is if you're working here, whoops, I want to clear this plot and close this, and I hit, and I go back and activate this one, I can move this stuff over here so I can still see what I'm doing. Let's bring up a PV. Now, what the leak index is, and I need to explain what it is to explain one of the new features. You can see here that what it's doing is it's really comparing the trap gas on the compression line and the expansion line. So it's working up the compression line, comparing it to the trap gas on the expansion line. And it's giving you whether it's a discharge leak, a suction leak, or a ring leak. Well, in the past, there is some setup for this. So we're going to go back to setup. We're going to go to software options, and we're going to go to leak index. Now, leak index, in the past, you could only set up your sensitivities and define it for one machine. So if you had a multi-stage machine where you had 3 stages, you didn't have the ability to have different setups. Quickly, the smoothing factor, and we really haven't talked about smoothing, but you want to smooth. So to get rid of some of the pulsations. And a lot of this has to do, you set these up because of the pulsations in the unit, and you don't want the pulsation to affect the leak index. The leak index, this really, your 3 and 9% is where it starts comparing. Does it start comparing here, or does it start comparing here? That's what the above the suction line and below the discharge is. And then the sensitivity is, some people don't want to be told, or don't want to be said they have a leak until it's at a certain level. So we give you the flexibility to pick when it is actually called and when it says, hey, you got a discharge leak. So this is one of the new features that we have, is the ability to change your leak index setup for every cylinder. So I'm going to hit OK. And I'm sitting, we only have 6 minutes, and these Zoom sessions really kind of end right at time. I will say, before I show you the next one, if things get cut off, we're going to go ahead and try to answer questions for as long as we can if there's questions. I know there's been a few. But let's go to let's go to another. I'm going to clear plot. Once again, I'm going to bring up both the head end and the crank end on here. And I'm going to bring up, the rod low plotting. Now, rod low plotting is taking really the pressures And the blue line is the inertia. Let's bring this up full screen. So this would be the forces on the rod based on the weight of the piston and the rod. Where the green is really these pressures. How much gas? What is the pressure? This would be the gas load. And then the red line is a combination. Analysts a lot of times will want to play around in the setup, machine geometry setup. If you go over to compressor, you can see that you actually put in piston and rod weights and crosshead weights. While you're analyzing, people have wanted on the fly to modify these numbers. So they've added the ability to, on the fly, just like you can adjust the clearances, you can actually adjust your weights. And this is just a technique to help you do analysis. Let's say I'm on cylinder 4. So notice how this now changed. So where these are crossing, so this would be where my pressure reversal, all of that, the crosshead, it changes. If I change my crosshead mass, let's say I change this to 100. Now my degree reversals change. So this is another new feature that is to help the analyst as they're monitoring the machinery. And a lot of times this is done when you're comparing it with, we're not really talking about vibration today, but if you have a knock and you have that on the plot, this is where this can be really beneficial. The last thing I want to talk about, and we have about 3 minutes, which means I'm not going to be able to, you know, sitting in true fashion to the Mary Chapman talking all the time. I am running out of time. The last thing I want to talk to you is really a VE sensitivity. This is once again, this is some spotlight data. And I'm going to bring up, I told you I use flow balance quite frequently. And this is some data that we were taking where my flow balance was all over the place. It went everywhere from 1 back down. And that was on 3C. I compared that, and I'm going to get rid of some of these because I want to show you one other feature. And I'm going to look at I know that volumetric efficiency will actually affect what your flow balance is, because your volumetric efficiency affects your capacity calculations, what affects. But this is what I wanted to show you, is that if you're plotting, and this would be true, I'm showing you on trend data, but this would be true on vibration data, it would be true on pressure data, wherever. Anytime you have a lot of variation, because flow balance is a number of 1 and this one's a number of 80 to 90, it really, you can't see what's going on down here. So there's something called the strip chart. And the strip chart, as you can see here, is, and now it's plotting each one by itself. The strip chart, and really what was happening here is, once we saw the flow balance was very erratic, the volumetric efficiency, what was really happening was the pick of the VE. And if you go look at I'm going to do this right here. And if you look here, here's another key. The system will actually try to pick the VE. You see it's saying 94. That's how much time it's moving gas, whether it's coming in or out of the cylinder. And sometimes, especially on hydrogen compressors, there's the wrong pick. And that's what was happening on this. So what we've added, if you go to setup, and this is the last thing because it's 12 o'clock, and I go to calculations, we've added a new algorithm that actually does a better check. And we've allowed you to set up the sensitivity. So if you have a methane, you're midstream, probably don't have to worry about this. If you have a hydrogen, which is a lighter gas, you might want to play around with this. That's about all the time that we have. It is already 12 o'clock. And I hope that you guys have gotten, thank you, Rocky. I hope y'all have gotten some things out of this. Rocky and I will stay on the phone or stay on and see if there's any questions. You know, maybe we have a Windrock MD part 2, because we've just started touching on all the features in Windrock MD. But I hope y'all have enjoyed it. Be on the lookout for more webinars coming up. And thanks a lot. You want to